Hi, in this video, we're going to look at subnetting within a natural octet boundary. And this should bring a lot of things together for us. Okay, so once again, subnetting IPv4. All right, to subnet IPv4, we actually have to borrow from the host portion to create the subnets. All right, so when subnetting on a natural octet boundary, say from a /8 to a /16 or a /16 to /24, makes it fairly easy. But when subnetting within a natural octet boundary, like /24 to /27, most times we have to actually look at the binary to fully understand what those subnets look like. Okay, so let's use this as an example. We have our host at 10.4.16.66, and it has a subnet mask 255.255.255.0. We do the AND operation, okay, and we just copy the network bits, and we put all zeros in the host portion, and that gives us our network address. All zeros and a 1 gives us our first host. All ones and a 0 give us our last host. And all ones gives us our broadcast. So we can see that this host belongs to the 10.4.16.0/24 network in this case. First host is 16.1, last host 16.254, and the broadcast 16.255. And yes, we can see that this host IP address, 10.4.16.66, falls in that range of valid host addresses. Okay, we have 8 host bits. That's 2 to the 8th minus 2 gives us 250 addressable or usable hosts per subnet. What if we wanted to actually take this subnet, this network? Remember, subnetting is just taking a network and subnetting it further. Okay, or subnetting is just taking a network and borrowing bits from the host portion to create the subnets. There we go. All right, we have this host, same host IP address, but let's say we want to take this network and actually subnet it. Okay, take the 254 usable hosts, 256 total hosts on that subnet, and create smaller subnets. Okay, divide it into smaller subnets. So we're going to extend the mask 3 bits to a /27, 255, 255, 255, 254. So our mask moves from here, from a /24, to a /27. We extended it 3 bits. Okay, this will give this device will now be a member of this network. Okay, just copy the network portion, all 27 bits, including the subnet bits. It's part of the network portion. That's where the mask is, still ones. 010 gets copied down here. Sometimes people make a mistake of putting zeros here. No, copy these first 27 bits. We put all zeros in the host portion. That gives us the network address. All zeros and a 1 gives us the first host. All ones and a 0, the last host. All ones, the broadcast. So now we see that this host is now a member of this network with this mask, /27 mask, 10.4.16.64 subnet or network with a /27 mask. The first host on that network is the .65, the last host .94, the broadcast .95. And we can see that this host 10.4.16.66 is a member. It's in the range between .65 and .94. Okay, so here is the host on its new subnet, 10.4.16.66 with the /27. Okay. The number of subnet bits are 3. That's what we borrowed from the previous network to create this subnet. How many subnets did we create? Well, 3 bits, 2 to the 3rd, gives us 8 subnets. The number of host bits we have for each subnet is 5 bits. 2 to the 5th, which is 32, but we subtract 2, can't use the network address, can't use the broadcast, gives us 30 usable hosts per subnet. Okay, let's take a look at what would be all the subnets with this /27. Okay, we said that the number of subnet bits is 3 bits. 2 to the third gives us 8 subnets, and there they are. There's all 8 subnets, 3 bits, starting with 3 zeros going to 3 ones. Gives us 8 total subnets. The number of host bits is 5 bits. So how many hosts can we have on this subnet? Well, total of 32 total addresses, but 30 usable hosts, because we can't use the network and can't use the broadcast addresses to be assigned to devices. So each one of these 8 subnets from 000 to 111 would have that range of 5 bits for its host addresses. Kind of a nice way to visualize it, don't you think? Okay. Our usable addresses, however, are, let's see, we have 8 subnets, 3 zeros to 3 ones. Okay, that gives us 8 subnets. But we only have 30 usable hosts per subnet because we can't use the network, can't use the broadcast. So that gives us 8 times 30 is 240 addressable or usable hosts. Okay, how many, remember when we did that, when we talked early about the concepts of subnetting, we lose 2 addresses per subnet. So actually when we subnet, we lose in IPv4, we lose some addresses. How many did we lose when we subnetted? Well, for each subnet, we can't use the network address and we can't use the broadcast for each subnet. We have 8 subnets times losing 2 addresses per subnet. 8 times 2 is 16. We've lost 16 addresses that we cannot assign to hosts. Now, looking at our host address, we see that it is on subnet 010 right here. My arrow didn't quite go far enough. 010. That's the subnet it's on. The host is 00010. There's the host. Okay? So we could see that this device is a member of this subnet and is this host on this subnet. Kind of cool. Kind of interesting way to look at it. I wanted to see what are all the subnets I have. Let's take a look. Again, we have 3 subnet bits, 3 zeros to 3 ones. That gives us 8 subnets. We said we had a total of 5 bits for the host left over. 5 bits. That's 2 to the 5th, 32 total host addresses. Of course, we can't use 2 of them. The network and the broadcast can't assign those to devices. So 30 usable hosts per subnet. But we have 32 host addresses. Okay, let's take a look at our first /27 network address. How do we look at our first one? Well, that's the 3 zeros in the subnet portion. 3 zeros in the subnet portion. Okay, with 5 host bits. Okay. So our first subnet /27 subnet is 10.4.16.0/27. What would be our next one? Well, there's actually an easy way to do this. One, we can do it in binary. We take our 001, increment the subnet 001, we have a 32 here. So the next octet is 32. Okay, but remember we have 32 total hosts per address. Look at this. We just increment this network by 32. The first one by 32, we go from 0 to 32. Take a look at the next one. Next subnet is 010. But remember, we said each subnet has a total of 32 total hosts. Just add 32 to the previous subnet. We go from 32 to 64. What do you think the next one's going to be? 10.4.16. What do you think? 32 total host addresses per subnet. Let's increment it by 32. We get to 96. And we could see that these subnet bits are following what we have here from 000, 001, 010, 011, etc. Let's go through the rest, just incrementing by 32 until we get to all ones. Okay, so each one incremented by 32, the number of total number of host addresses not counting the 2 that we subtract, or not decrementing the 2 that we subtract. Okay? Kind of nice, easy way to see the subnets. Okay, let's take a look at the relationship between these subnets, because that's kind of cool. Notice that the first host is always one more than the network address. Well, that makes sense because it's the the network address is all zeros in the host portion. The first host would be all zeros and a 1, so it's going to be one more. Our last host is always going to be one less than the broadcast. Well, that makes sense. Our broadcast is all 1s. Our last host is all 1s and a 0, one less. Okay, that makes sense. Now look at the relationship between the broadcast address and the network address of the next subnet. It's going to be one more than that. So our broadcast ended in .31. Our next network address begins in .32. Okay? So you can see this throughout all of our subnets. All right? It's the beauty of looking at it in the bits, so that we can actually see how these numbers are created. All right. Okay, I hope that helps you understand a little bit more about subnetting. If you can do the subnetting examples that I've shown you in these videos, you can subnet anything. Just follow those same rules.